Yeah, good afternoon all. So myself, I'm Vijay. Like I hold 18 plus years of experience, which includes 8 plus years of experience in Hadoop and Spark environment. Yes. So before I start, can anyone please confirm whether my voice is clear, where the screen is visible or not?
Yes, sir, it's audible and it's visible.
Right. Thank you. So in this course, right, it's a big data. I'll be discussing about big data. Hadoop is going to be covered, right? PySpark. So before I go with the PySpark, right, Python is going to be covered. PySpark, Linux. So this Hadoop, Python, PySpark, and Linux, right? So Hadoop, PySpark. So this PySpark is mostly used today. Like it has got great boom in today's market, right? Spark with the Python implementation, right? So I'll brief you about how the training level goes at the end of the session. Now, what is big data? What is big data, right? Why Hadoop? Drawbacks. So what are the drawbacks we observe in the current databases? Why we are going with drawbacks of current databases? Hadoop advantages. Hadoop and PySpark. Hadoop advantages, not yes.
Hey, hi Vijay, sorry to interrupt you.
Yes, yes.
These all things covered last time, right?
Hadoop, Hadoop and Hadoop ecosystem components.
Hello, I'm audible.
Yes, Manoj. Today there is a demo. Let Manoj.
Yeah, last time I attend already, Vijay, and you said next time regular classes.
Okay, okay.
We,
From tomorrow you can attend, right? If you're already done with this. Hadoop ecosystem, Hadoop advantages, right? Hadoop ecosystem components, right? So what is big data? Why Hadoop? Drawbacks of current databases, Hadoop advantages, Hadoop ecosystem components. So what is big data? So the name itself saying like huge volumes of data, right? Stores like KBs of data. See the data storage units like KBs, MBs, GBs, terabytes, petabytes, exabytes, zettabytes, etabytes, so on, right? If you see like GBs of data, you should have seen, TBs of data, you should have seen, but petabytes of data, right? Yes. Petabytes or exabyte of data, is it getting generated in the current world means? Yes. Examples of petabytes or exabytes of data generation. Like if we talk about the social media like Facebook, right? Generating huge data. Facebook is generating like in a minute. What is the data generated by Facebook in a minute? How many posts and videos are getting circulated? What is the storage capacity of Facebook? Means what is the to store the millions and trillions of users, right? Facebook has got to store all the posts and videos. What should be the storage capacity? Not in GBs or in TBs, right? Petabytes. Even if you talk about any bank, right? If we have a bank like SBI, which has got branches throughout the city, throughout the state, and throughout the country, right? Lakhs of branches throughout the country for SBI, which has got millions of customers making multiple transactions. So we'll see like huge data, right? Apart from this, We talk many other applications, not only like Facebook, we have got many applications which generate huge data. If I take 1 minute transaction in say in a minute, how many post data generated by Facebook in a minute and Twitter tweets, what is the data generated by Twitter in a minute? And everyone querying in the Google, right? Google queries. What is the data generated by Google in a minute? And YouTube videos upload, right? YouTube videos upload, what should be the storage capacity to store all the videos like Facebook, Twitter, Google. And if you talk like Gmail messages, right? Yes. What should be the storage capacity to store all the messages and even bank transactions? Bank transactions and for telecom transactions and for e-commerce, right? E-commerce. Flipkart or Amazon, right? Flipkart or Amazon transactions. So everywhere you see like huge data is getting generated. Yes. So if you see like in YouTube, Google, Facebook, Twitter, bank transactions, telecom transactions, e-commerce, all this just storing huge data, like in petabytes of data, right? Yes. So in a minute, we can see this, right? So to store this data, right? To store this huge data, yes, to handle this data. The current databases can handle the current databases like Oracle, MySQL, if you talk about DB2 or this, if you go with specialized databases like Teradata, Netezza, Vertica, all these current databases used for OLTP online transactional processing, they can handle data up to some extent, like in GBs or in TBs. But to handle unlimited data, right? Yes, to like petabytes of data. So as a solution to all the storage level problems and processing levels, right, we have got a framework like Hadoop, which can store unlimited data storage and unlimited data processing. If you see like if you see the current real world, right? If you see that huge data is getting generated, yes, exactly. Assume this is your data. This is your data which got generated, right? Yes. From last 50 years, 1973, 2023. Assume this is the data which got generated from the last 50 years. If you compare like the 2013 to 23, right? Last 10 years compared with the previous 40 years, like nearly 80% of the data what was generated from the last 10 years. See, if you see this is the entire data from the last 50 years. From the last 50 years, 80% of the data has been generated from the last 10 years itself. In the previous 40 years, only 20% of the data has been generated. Reasons for this huge data generation, like because of usage of technology, because of usage of smartphones, because of usage of internet. So huge data is getting generated. And what are the main sources from where this data has been generated? Mainly like three sources, right, from where this data has been generated, right? Mainly three sources, like social data, secondly, like machine data, and transactional data. Social data, like data which has been generated from the social websites like Amazon, Flipkart, all this. Machine data, right? Data which has been generated by reading or scanning the barcodes RFID chips, such kind of data we see like machine data, transactional data from day-to-day operations, like bank data, telecom data, right? And mainly this data is going to occupy three types. Structured data, yes, structured data, unstructured data, and semi-structured data. Structured data, unstructured and semi-structured data, right? Structured data, which is organized in the form of rows and columns, right? Like Excel sheets, database tables. Unstructured data, right? Unstructured data, like chart messages, articles, images, videos, all this comes as unstructured. Semi-structured means which is not fully structured, which is not fully unstructured, like PDF files, JSON files, all this comes as semi-structured. So the today, like if you talk about the databases which can handle only structured data, which is in the form of rows and columns. But this unstructured today, the if you see that huge data, whatever is being generated, right? It's going to occupy most of the time. We see like unstructured data or semi-structured data. The biggest challenge to handle or to process this unstructured or semi-structured data, right? So where databases can handle only structured, but frameworks like Hadoop can handle structured, unstructured, and semi-structured all varieties of data. So as a solution to all the storage level problems and processing level things, right? We have got a framework like Hadoop, which is meant for both storage and processing, which is meant for storage and processing, right? Yes. Yeah. For storage, okay. If you talk about any technology which either store or process the data, either like C or C++ or Java, right? Or .NET, they are meant for processing. Talk about like Oracle, MySQL, DB2, all this they are meant for storage. But Hadoop performs both storage and processing. For storage, we use like HDFS, Hadoop Distributed File System, and for processing, it uses a technology like MapReduce or Spark. So his Hadoop performs both storage and processing, that to unlimited or huge data storage and processing. And for storage, we use HDFS, a file system, because databases has got some drawbacks, right? Despite of those, still Hadoop doesn't go with this. And for processing, MapReduce or Spark. Okay. So what are the drawbacks? Understood, right? Why Hadoop is required for huge data storage and processing? We talk about the drawbacks of the current databases. Drawbacks of the current databases, yes. And you may ask, you may get a query, right? So when Hadoop is able to perform both storage and processing, what is the necessity of the current storage and processing technologies when Hadoop is doing both? Okay. So you need to understand Hadoop is for batch applications. Hadoop is for batch applications, for batch processing. There are two types of applications, right? There are two types of applications. So Hadoop is meant for storage. Hadoop is meant for processing. For storage, HDFS, and for processing, MapReduce, we use like PySpark. Hadoop is meant for batch applications. It is not for online applications. Uh, Batch applications, there are two types of applications: online applications and batch applications. There are two types of applications, right? Online applications and batch applications. User interactive applications, right? User interactive applications. Here, user gives the input. In all the online applications, user gives the input. Making a online transaction or booking a movie ticket, right? All this comes as online applications. For batch applications, user is nowhere required here. Here, user non-interactive applications. Here, user is nowhere required. Railway ticketing PNR status, automatically your waiting state. The user has nothing to do with that. Yes. Generating credit card statements for millions of customers. Phone bill statements for millions of customers. Okay. So Hadoop is meant for batch applications, right? And the drawbacks of the current databases, most of the databases, right? For the most of the databases, limited storage, right? Yes, in GBs or in TBs. And most of the databases, no parallel processing. And in databases, if volume increases, speed decreases, right? If volume increases, speed decreases. Yes. Observe these queries, right? Yes. Yes. Select a total amount from sales 1 has got 10 records. Total amount from sales 2 has got 1 lakh records. Total amount from sales 3 has got 1 crore records. If you observe these queries, which query executes faster? The first query executes, right? Like it has got 10 records, total amount of 10 records, total amount of 1 lakh, total amount of 1 crore. Query to query, as this volume increasing, speed decreasing, right? Complexity increases, speed decreases. Complexity increasing, speed decreases means total amount from sales 1 lakh. Total amount, average amount from sales 1 lakh. Standard deviation of amount. For example, here total amount, average amount, standard deviation of amount. Query to query, as this complexity increasing, right? Means average amount is a two-step process. First sum to be calculated, next average has to be calculated, right? As compared with the first query, second query is going to take more time. And as compared to the second, third is going to take more, that as lot of internal processing required for this. Databases can handle only structured data. Databases can handle only structured data. They cannot handle unstructured or semi-structured data, right? The major drawback with the databases, they can handle only structured data. So if you want to take reviews for a particular movie, right? User and review. One, movie is good, 0 means that movie is bad. So giving the feedback in the form of ones and zeros. They're giving the feedback in the form of ones and zeros. Can you write an SQL query to count the number of ones and zeros? Means yes, single grouping and single aggregation, right? A review wise count I want. Review wise count from reviews table, from reviews, group by review. Review wise count I want from reviews table, group by review. So if I see this, if you observe this output, right? Review 1, how many people saying it's 1? 90. Assume that you have the output as 90 and 10. Means 90 people saying the movie is good, 10 people saying movie is bad. But generally the reviews won't be giving in the form of ones and zeros in their own text format. First person saying movie is good. Second person saying this movie is not good. This way they are giving in their own text format. But if they are giving in their own text format, right? Yes. Then can you write an SQL query to count the number of goods and not goods? Not possible, right? So this kind of data can't be handled by databases, right? So the major drawbacks are can handle only structured data. If volume increases, the speed decreases. No parallel processing in most of the databases and limited storage. And here coming to this Hadoop advantages.
No parallel processing means, what do you mean that?
Parallel processing means here if we talk about, 1 second. If we talk about a database, right? A database table is there. It is stored in a single system or multiple systems. If you talk about a database table, right? How the table is stored? Within a single system or multiple systems. See, it's stored within a system and executed by system one.
Mm-hmm.
Okay. So this database table, right? It's stored in a single system and processed by the system. But in the case of Hadoop, right? If you got some data set in Hadoop, if you got some data set, it is going to be divided into smaller parts. Think it is of 2 TB size. For example, in Hadoop, it follows master slave architecture, single master and multiple slaves, single master and slaves. See, one system will be taken as master, all the other systems will be taken as slave. S2, S3 up to Sn. So this is your data. Each system has got 1 TB capacity, 1 TB, 1 TB, 1 TB. Here your data, your file size f1.txt has got a 2 TB. So this 2 TB cannot fit into any of this system, right? So in Hadoop, this file, any file, if it's a small file or a bigger file, it will be divided into smaller parts. Smaller parts. Each part will be stored across multiple systems. Each part is going to be stored across multiple systems and are processed parallelly. It means here two things you observe. Data, whatever the data is distributed across multiple systems and data is processed by multiple systems parallelly. That's why very high speed you can see. Means even it is 2 TB or 20 TB, right? The file is going to get distributed across multiple systems and processed by multiple systems parallelly. That is the two advantages you see here, right? Yes. This master, these are slaves, slave nodes we say. Systems, master node. In Hadoop terminology, master node called like name node. And these slave nodes we call like data nodes. Master node, name node. Data nodes because data is getting stored within this and data are processed by this. Data storage and data processing happening. But what is the work of master node? Assigning the task to these systems, slaves. And whenever a new task comes, to which system to be assigned. And if any system fails, the task of that system has to be assigned to other systems. Everything taken care by the master, right? So Hadoop doesn't follow client server architecture, not request response architecture. Hadoop follows master slave architecture, single master and multiple slaves. So Hadoop cluster means group of nodes. Nodes means CPU systems connected in a network. See this right? Group of nodes or systems connected in a network. We call this as a cluster. In this, we have got two types of nodes. Just now I said master node, name node, slave node, or data node. Master node responsibilities is one is assigning task assignment to the slave, load balancing, whatever the load should be balanced among all the slaves equally. Fault tolerance means if multiple tasks are executed by multiple slave systems, suddenly if any one system fails, the task of it has to be given to any of the other slave. That process we call fault tolerance. Health monitoring means, right, before assigning a task to a slave, the each and every slave health status is maintained by the master. Slave node responsibilities, storing the data and processing data. Storing data and processing data. Now coming based on this, later I discuss in brief about this Hadoop architecture, storage architecture and processing architecture, everything in brief. Advantages of Hadoop, right? Unlimited data storage. Unlimited data storage because of a feature, horizontally unlimited scalability. Advantage means why, how Hadoop can perform huge storage, unlimited data storage, because horizontally unlimited scalability. There is a feature, right? In Hadoop, if you got master, multiple slave systems. Today, if you are running a business, right, with very less number of nodes, assume 10 systems. Tomorrow, your business has increased, customers have increased, branches have increased, data is increased, means number of systems. Horizontally, your slaves also need to be increased, means horizontally unlimited number of slaves can be added. There is no limit on the number of slaves we can add to this. Yes.
Is it for only horizontally? What is the meaning of vertical also nowadays? The cloud technologies are following the horizontal and vertical scaling, right? But Hadoop is supporting only horizontal. What about the vertical scaling?
Horizontal scaling. Hadoop is following horizontal scaling. Means horizontally you can keep on adding. One will be the master, other will be the slaves, right? So horizontally unlimited number of slaves can be added.
Suppose if it is not required, we can reduce that one, right? Suppose
Yeah,
when we are adding on that, suppose if it is not required, can we reduce that one
yes,
on the
yes,
missions?
yes, we can increase or decrease. That is what we can say commissioning and decommissioning. Yes.
But
Whenever you want
but
to add, you
price
want to,
wise, it's once we are going to investing on that, right? That time, even though if you are decommissioning of that machine, no use at all. Am I
so
correct?
depending whenever depends upon the incoming data, right? So before we go with that, right, we are going to uh, creating a cluster of n node cluster, we say 40 node cluster, 70 node cluster, right? What, how many nodes required, right? Depending upon the incoming data, you are just going to arrange that cluster. You are creating a cluster, right? What is the data, what is the incoming data for every day, how much data it's coming, depending upon that, the number of nodes required, data nodes required, right? Everything will configure.
Okay.
And very high speed processing. Just now I discussed, right? Very high speed because of parallel processing, very high speed processing because of parallel processing, because your data is distributed across multiple systems are running parallelly, executing the same file, right? Same data file. So parallel processing, because of this parallel processing, very high speed you can see in Hadoop. Can handle all varieties of data, all varieties like structured, semi-structured, and unstructured. And open source, no licensing required. Most of these products of Hadoop are from Apache, right? So no licensing required, right? and it has got commodity hardware. Commodity hardware means it can run on any systems. It doesn't mean that Hadoop you need to have highly configured systems. It can run on any system, right? And it can be configured on any systems. Yes, that we say like commodity hardware. Means so what all the systems, it doesn't mean that all the systems should have the same configuration. Can have of any configuration. So mainly unlimited data storage and very high speed processing, all varieties of data. And so if you want to see the speed of Hadoop, right? So already many tests were conducted, right? Like Yahoo has conducted a test to check the speed of the different databases. It has taken a table of 100 TB size consisting of 1024 columns. The task was sorting based on 16 columns. So the time taken by different databases. Oracle has taken 3.5 days to process this 100 TB data of based on 16 columns. MySQL has taken 6 days. Teradata, that's a specialized database used for data warehouse. Just it has taken 4.5 hours. Netija, another specialized database used for data warehouse, has taken 3 hours. Finally, Hadoop has taken 3.4 minutes. Hadoop has taken 3.4 minutes. Latest version of Hadoop has taken, right, 1.2 minutes. So here it has taken minutes of time. It has taken days and hours of time, right? Yes.
What is the latest version on that?
Hadoop 3 version. Why databases like Oracle can't support unlimited storage? We have got many databases. Why these databases can't support unlimited storage, huge storage? Yes. So if databases has got some limit, even databases has got can go with multiple systems. It can have multiple slaves. Databases they have got some limit on the slaves. Oracle can go max of 256 slaves. 256 systems or slaves. It can support up to 256. Even MySQL 54, but MySQL Express 256 systems, right? Nodes. DB2 and SQL Server also like it can go with 256. Up to 256 systems can be connected, right? But specialized databases like Teradata, Netija, Vertica, they can go with 512 nodes or systems for storing the data. Currently, this Teradata Netija going with 1024 systems, slaves for storing, right? So still, we cannot say this thousands of slaves if you're connecting also, unlimited data storage is can't be achieved. So there is a beyond this Teradata Netija, they are supporting 1024 slaves. Still, we cannot say like it's unlimited data storage, right? But there is no limit. There is no limit on the number of slaves. There is no limit on the number of slaves that Hadoop can have. So Hadoop can have unlimited number of slaves, right? Horizontally, unlimited scalability. There is no limit on the number of slaves. Yes. Yahoo, when first time implemented Hadoop, it went with 4,000 slaves for storing its data. Currently, Yahoo going with 12,000 slaves for storing its data. Facebook, when first time implementing Hadoop, went with 8,000. Currently, it's Facebook going with 42,000 slaves for. So there is no limit on this number of slaves like 10, like 1,000 or 256, right? Like this current databases are specialized databases where there is no limit for Hadoop. It can go with 40,000 or 50,000 or beyond that, right? Any number of slaves. That's why huge data storage is possible in this. So Hadoop proven in the market storage point of view and processing point of view. Today, like if you see, there is a huge data is getting generated. Previously, if you see 1990s or in the early 2000s, right? We see like KBs of data. We should have got some floppy disks or CDs for storing the data. But now, even like TBs of data is a small storage, right? You are, even if you see in the mobile phones in the earlier stages, you've seen 2001 or 2002, right? Like you have got like 150, what is that? 256 MB of storage, internal storage, 256 MB of internal storage. But now 256 GB is also a very small storage, right? GBs or TBs of data. So as data is increasing, previously a floppy disk in 1990s, we used to carry floppy disk 1.4 MB. But now in 1.4 MB in 1990s, you can store like 30 to 40 pictures or images in that 1.4 MB. But now you are not able to store a single smartphone pic in it. Means data is increasing enormously. We need to have some proper storage system. So not only storing it, even processing that huge data in quick time, where industry is expecting, right, the results in quick time. So the quick storage and processing tool, Hadoop is one. Hadoop framework performs both storage and processing. But we have got another lightning fast, very fast lightning technique, which is faster than Hadoop also. Spark, PySpark, we say, right? PySpark. So today in the market, right, both Hadoop and PySpark both combinedly used for storing and processing. Already I said it's Hadoop has taken minutes of time, right? This database have taken days and hours. Spark is 100 times faster than this Hadoop. Then see the speed of Spark, PySpark, right? This has taken minutes of time, but compared to this PySpark, it has 100 times faster than this Hadoop. Means where it follows in-memory computation. In-memory computation means storage and processing, everything happens in the memory level in Spark. Now, if we discuss like PySpark, right? So both storing of data and processing of data, both happening in the RAM level, memory level. That's why very high speed that is in PySpark. We discussed that also, right? We have got inbuilt transformations actions there. No need to write huge codings, right? Yes. Hadoop ecosystem components, right? Yes. So as part of this course, Hadoop and
And
so
Vijay,
yes.
I need one more doubt on that. Actually, for the advantages of Hadoop, if you go to open source, no licensing required.
Mm.
What about the security level? How we are going to implement on the if the no licensing required? How the security will be happening on this?
Security level you're talking,
Yes.
if no licensing is required. Okay. So so for that also we have got separately we'll be discussing about security levels also, right? It has got highly secured. Whenever you go, when your data is stored across different systems, right? Compulsory the security things. Hadoop has got those things. Hadoop and PySpark, we have got separate discussions on that, right?
No need to pay on that security level also.
See, Hadoop means run every node on the cluster. We are just installing that, right? But
Okay.
maintaining the security, means maintaining the security levels.
Mhm.
To whom to be given the access, who can access it, all those will be provided. Who can access the data and how the data is stored, everything, right? We have got that levels maintained by this Hadoop.
Okay.
Means this access privileges won't be given to, means we're talking about the data, right? But it's a software, okay, it's a open source, no licensing can be, okay. But whenever you talk about the data, right, who can access? Yes.
Okay.
Yes. Here we have got some components, Hadoop ecosystem components for storing and processing the data. HDFS is meant for storing data, right? We doesn't use any databases. Databases has got some drawbacks. Can't handle that today, like huge data generating is in structured, unstructured or semi-structured, like JSON files, PDF files, images, and many other data, right? So to handle the data, we are using to store the data, we are using HDFS, Hadoop Distributed File System. And for processing, we have got we are seeing components like MapReduce meant for processing, Hive is meant for processing, and Spark, PySpark is meant for processing. And people who wants to go for PySpark means the companies who are choosing PySpark means need to maintain huge RAMs required. If we have got huge data, right? Huge RAMs to be maintained, right? Yes, if we are able to maintain that huge RAMs, the company is just choosing for PySpark. Map Hive, it's a kind of data warehouse kind of environment in Hadoop framework. It's a data warehouse kind of environment in the Hadoop framework, right? It is also meant for processing. It has got a HQL language, right? HQL, Hive query language, similar to SQL language. So if you want to perform, means if unstructured data, means whatever semi-structured, unstructured data, making the data structured and creating tables using Hive, creating tables, and on that table you're performing querying, Hive querying, right? HQL, 90% HQL similar to SQL, but only thing is update and delete operations can't be performed. Remaining all can be performed as part of SQL, right? Scoop. Generally, how you are going to bring the data to HDFS. HDFS is a huge storage, right? From where you will get the data from. From where you are going to pull the data. From what are the data sources, right? Like from databases, from different OLTPs, from different databases. We have got a component called Scoop for importing data into HDFS. For data ingestion tool, right? Scoop is one of the data ingestion tool. From different databases, you are bringing the data to HDFS, and from HDFS, all the processing components like Spark, Hive, they take the data from HDFS, process it. After processing, again, you can export the data. So Scoop is a component which is used for importing data, bringing the data to Hadoop environment. After processing the data, after that, export the data to the databases. This works only for database and Hadoop only. Scoop is for only database, SQL, and Hadoop. The first two characters of this and last three characters of this forms a scoop. NoSQL databases, right? NoSQL. Today, if you see most of the data, most of these e-commerce sites, they are using NoSQL databases. Schemaless behavior, random access. This is the advantage of this NoSQL database. If you talk about this SQL databases, right? Schema compulsory. First record to the last record, same number of columns has to be maintained. But in NoSQL databases, record to record, different number of fields can be maintained. First record with 5 fields, 5 columns. Second record with 7, third record with 10. In this way, record to record number of fields or columns can be maintained here. NoSQL. NoSQL is nothing but not only SQL. HBase is one of the NoSQL database like Hadoop's database, right? HBase is one NoSQL database. Not only this, we have got many NoSQL databases. HBase, Cassandra, MongoDB, Riak, Peanut, Neo4j. In this way, many, but famous one is like HBase, Cassandra, and MongoDB, right? So in here in Hadoop, I discussed like HBase, and in Spark, PySpark, I'll also give knowledge on this Cassandra. And also provide you the knowledge on Flume and Kafka. Streaming data technologies, right? Streaming data, capturing live streaming data. Live streaming data means streaming data, nothing but data which keeps on incrementing. Data which keeps on incrementing. Data which keeps on generating. Data which keeps on generating. Such data we call it like streaming data. Okay, Zookeeper. So for this streaming data capturing is done by components like Kafka, which is mostly used today. Right. Zookeeper controls and coordinates all the other Hadoop components, right? Yes. And PySpark, right? Mostly our discussion will be on this PySpark, Spark core programming, Spark SQL programming, and this is Spark streaming and Spark ML machine learning library also, right? Today, like it also supports many machine learning libraries used for data analytics. So here PySpark, it's a very fast computation technology, right? It has got great boom in today's market, right? It is in-memory computing system. In-memory computing system means both storing and processing, both happening within the memory level, right? Yes. We talk more on this PySpark, right? So yeah, it is a distributed PySpark also, right? It's a distributed cluster computing framework. It is also given by Apache Software Foundation. So I can say it's a general engine for big data analysis, for processing and for computations, right? Yes. So this PySpark is one of the Python API. It's a Python API, right? To use Spark. It's one of the PySpark package where it has got many modules and functions and classes present within it. So it is a lightning fast technology, right? It is designed for fast computations. So one of the demanding tool for data engineers to work with bigger data sets or huge data sets, right? Like if we see today, like if we just say the PySpark jobs, lot of jobs for PySpark, right? And that to the package will be huge packages for PySpark where they'll be expecting the same technical skills required, right? Yes. It's a PySpark mainly used for it's a data flow language. It's a data flow, right? Creating data pipelines, ingesting data to databases, running ML algorithms, working with graphs and DSS streams, right? So if you see like huge amount of data is generating, right? So the data, whatever generated is going to have some patterns, like some market trends, customer preferences, user preferences, right? So we need to just extract some data, extract some valuable information from that. So PySpark is one of the main tool, which is a more efficient tool to perform different types of operations, performing multiple tasks, right? So combining Python and Spark together, combining both Python and Spark is it's a very efficient way, right, for the world of big data. So that's why like Apache Spark community, right? It has came up with a tool called PySpark. My discussion, like my total, have a lot of discussion on this PySpark, right? So combining Spark and Python will be the very efficient way. So there is a Spark, PySpark, we are saying Spark is implemented using Python. Spark can also be implemented by using another language called Scala. Previously, it was very much used, but now PySpark is mostly preferred, where it has got powerful libraries even for graph algorithms, for streaming, and for machine learning, right? Yes. So is the PySpark used in our real life use cases, right? In the especially in this, if you see in the online streaming, like online entertainment platforms like Netflix, using this PySpark for real-time processing. It process nearly 450 billion events per day. And even in e-commerce, like even this Spark is implemented in e-commerce websites like Flipkart, Amazon, right? For advertising and also for customer preferences and for recommendations. Person purchasing one item also like the other item, right? In this way, some kind of recommendations, right? Recommender engines, and that is, and even some increasing the enhanced customer experience and
What is the Scala? Can you come again? You are telling about the Scala on that. Do you require to study on that? Not required, right?
Not required. So Spark today like Spark, right? Very high speed processing, very high speed, but it can be implemented in multiple languages. Mostly used languages are Python, Scala. The Spark execution model remains same. What all the Spark functionalities, inbuilt functionalities, features, everything remains same in both Python, but only that coding wise language you are implementing in Python or implementing using Scala. But you can also implement in two more languages, Java and R language. But these two are very less preferred. Python and Scala are mostly preferred today for implementing Spark means the language, but whatever the Spark related functionalities remains the same, like data frames, RTDs, data streams, all this remains same in both but the language, the coding is going to differ, right? Thus, the Spark with Python, we say like PySpark, and the Spark with Scala, we just say it as Spark only, right? Yes. Right. Okay. This is what PySpark. This is all I'll be covering as part of this, and in which we will be discussing a lot on this PySpark. Okay, see this, yes, course content for this. What is first introduction to this big data? HDFS in brief, right? Hadoop distributed file system. How we are going to store the data. What is that role of this name node, data node, secondary name node, job tracker, cost tracker? Previously, we have got recently like resource manager, node manager, fault tolerance mechanism, map reduce component, scoop for import or export operations, scoop importing or exporting, how we can import and export data from database to Hadoop, Hadoop to database, right? The interaction, right? And also while importing, we can perform various transformations, filtering operations, merging operations, grouping operations, incremental imports, and defining scope jobs. Yarn, yet another resource negotiator, right? It, like yarn architecture, yarn components, how the yarn processing is going to happen, right? And one by one component in brief. Yes, and NoSQL database I discussed, right? Like NoSQL, not only SQL, and one NoSQL database HBase is covered, is going to be covered in brief. And one of the important component of Hadoop Hive, right? For data warehouse kind of environment and for querying, right? Yes, Hive Metastore, loading data from local files to and creating tables, internal tables, external tables, working with unstructured, working with XML, working with JSON data, URL weblog data. Only on Hive, right? There are a lot of jobs on Hive. If you got knowledge on Hive and Hive joins, unions, inserts, local files, HDFS files, UDF, user-defined functions, UDAF, user-defined aggregated functions, UDTF, tabular functions, partitions, static partitioning, dynamic partitioning, multi-column partitioning, indexing, performance tuning mechanisms, dynamic bucketing in Hive, indexing in Hive, right? And integrations with NoSQL databases, right? That is total in brief on this Hive. Coming to this PySpark, lot of discussion on PySpark. PySpark, right? All these PySpark web applications, it's Spark sessions, context object, repartitioning, broadcast variables, RTD computations, persistence options, various way in memory in C-list format, disk, PySpark core computing, right? Fault tolerance mechanism, right? Aggregations and groupings and aggregations, single and multi groupings. Yes. Process of group by key, reduce by key. Yes. Reduce function, various transformations, various built-in functions. And one by one, each and every inbuilt transformation and action. This one by count by key, count by values. These are all the inbuilt transformations and actions. PySpark SQL data frame APIs, creating data frame. Yes, RTD data frame, and different functionalities. Collect with column renamed, where, filter, order by, group by, union, all types of operations. We have got many inbuilt functions, each and everything. And SQL functions, aggregate functions are there, window functions, date and timestamp functions, JSON functions, PySpark built-in functions. When lit, no need to write any code, directly inbuilt functions available. Substring, translate, overlay, date and time, timestamps, collect. Yes, all this. And the PySpark external sources, and with working with SQL statements, Spark with integration with Hive, Spark with MySQL integration, working with CSV files, JSON files, transformations and actions, narrow and wide transformations, adding new columns, dropping columns, renaming, adding new rows, handling nulls, joins, window function, deployment modes, local mode, cluster mode, right? And PySpark application stages and tasks, drivers and executor, building a Spark application, deploying Spark applications to cluster, and performance tuning. And PySpark streaming concepts will be discussed, and also integration with Kafka, and also like PySpark machine learning library, right? And for learning this Spark with Python, you need to have the knowledge in Python, right? So even this Python, in brief, like Python code programming, Python advanced programming, and this Python sessions, those who want to prefer, who want to have knowledge on Python also, yes, inbuilt in. So Python today, even not only for this big data or for this data science, Python knowledge is required. That too, not like overview of Python, right? In brief, because in PySpark, total coding implementation in Python, you need to have the in-depth knowledge of this Python coding, right? So everything Python basics, Python operations, operators, Python IDs. In real time, we use IDs, licensed IDs are there, and the free IDs are there, right? Working on all those IDs like Jupyter Notebook, Anaconda distributions, Spider, PyCharm, PyCharm Professional, PyCharm Community, right? And flow control statements, looping statements, strings, collections, list operations, tuple operations, sets, dictionaries, functions, modules, packages, errors and exceptions, file handling, object-oriented programming, regular expressions, database connectivity, Python, date and time, operating systems, related iterators, generators, graphic, and Excel workbook, data analytics, introduction to data science, Python, pandas, module, NumPy module in brief. That is numerical Python, right, in brief. Pandas and matplotlib, plottings and visualizations, generating different types of graphs, scatter plots, stack plots, pie plots. So everything we discuss on this HDFS and LFS, local file system and HDFS. And apart related to the software, everything I'll be providing you to your Google Drives. How to execute in different environments, I'll be going to show you, right? How to run this, execute these things in Jupyter, that is in Spider ID, in PyCharm ID, on this Linux VM environment, right? So this is Python, this PySpark, this Hadoop, and with all this implementation on this Linux. Yes, tomorrow I'll be going with the technical part, right? How exactly the data storage and processing is going to happen within this Hadoop environment, means how the data is getting stored, and replications, fault tolerance in Hadoop, how the processing and the storage, and how the data blocks of Hadoop. So tomorrow I'll be just starting with the technical part of this. And you'll be getting the video of it, session video of all this, what Hadoop, PySpark, Python, right? Class notes or clear notes with comments, tasks to work with, assignments and tasks. A WhatsApp group. WhatsApp group for technical discussions, right? If you got any error, you can just take the snap and keep in the group. So videos, class notes, tasks, assignments in WhatsApp. So as I said, here
Uh,
Hadoop components, just to give me 2 minutes, right? So I'll just come back to your queries. Fine. Hadoop, PySpark, Python, Linux. Means Linux up to what extent required, that will be discussed, right? As for what is required for this, not all the entire Linux administration. So this is this Python of 2 months. So this entire thing will be covered, right? Python, Monday to Friday, there are some classes going on, right? Morning or evening, you can select any one batch of mine. So Python batches, morning or evenings, nights. There are batches going to start. Every week there will be some batches on Python, and that will be from Monday to Friday. So it will be for 1.5 to 2 months that you can parallelly you can attend the sessions. So first, as we go with Hadoop, right? So by the time the Hadoop completes, your Python core programming will be completed, right? At least Python core and 60 to 70% of Python will be completed by the time we start with PySpark. So it's a weekend. This Python will be regular, right? You want to go with Python, right? It will be regular classes from Monday to Friday. And for Hadoop, PySpark, these things, these are weekend batches. Weekend only on Saturday and Sunday you'll have class, right? Saturday and Sunday, like 2:30 to 4:30 or 5 it goes. 2:30, like 2 hours on 2.5 hours on Saturday, 2.5 hours on Sunday. Like 4 to 5 hours you'll be getting per week. Like in that way, 12 weeks. 12 weeks means 3 months on this Hadoop and PySpark, right? In brief, because if you see that course content, the syllabus also, everything in brief will be discussed. All the sessions will be live sessions. Means you can interact during the session. If you got any query, you can just ask the name there. You'll be kept in unmuted status. So by the end of this course, right, or by 3 months, you'll be getting great command on this Hadoop, PySpark, and Python, all these things, right? Fine. So tomorrow at 2:30, you can follow the same today's link. I'll be starting with the technicals, right? That Hadoop storage, how exactly the data is getting stored and how exactly the data is getting processed, how it is divided into partitions, and how the partitions are distributed and how they are processed. So I'll be discussing multiple cases there. And in PySpark also, if you can see, we have got huge content. I am going to discuss all the inbuilt transformations and actions given by the Spark core programming, Spark SQL programming, and streaming process. Yes. Any queries from your side, anyone?
Hello.
Yes, yes.
Sir, can't we have, can we, mm, don't we have any only Hadoop course? Because I have taken PySpark course from you only previously. So only Hadoop course, do we have that?
Yes, yes. Only Hadoop, you can just talk. So you can see in the chart panel, right? 1 second. No, 1 second. One second.
Okay.
Okay. Okay, fine. How many demo? Okay, fine. So, okay, they'll be posting, you'll be getting a message, right? Now you can just call to that office team, right? Okay, you can ask only for Hadoop, or people who wants to only PySpark, only Hadoop, or only Python, or combination of Hadoop PySpark also. You can take that separate components you can take as a package. So as a package, this is for 15,000, right? For all this, mainly this Hadoop, PySpark, Python, Linux will be covered. If you already got Python knowledge, I doesn't want Python already. If you got knowledge on Python, right? Yes. So if you doesn't want Python, there is like you want like Hadoop, PySpark, Linux. You want this, right? On with excluding Python, the fee structure is 12K for it. With Python, 2 months of Python course of Python core and advanced. You can attend any of my Python batch, which starts on my either mornings or evening batches. All right. Will be 15K. Without Python, if you have got knowledge, it's 12K. Yes. And even if you doesn't want this PySpark, only like Hadoop and Linux, you can just talk with this online team, right? They face the fees for it.
Okay, sir. I will ask them. Yeah.
Somewhere I don't not much clear, like something like 5 or 6 they ask.
Okay. Okay.
Okay. So from any other queries, right, from your side? Yes. The softwares, everything I'll be forwarding. Only thing is you need to do with the practicals for the better understanding of the. If you're done with the practicals of today's session, next session will be very simple and easier. So on Saturday and Sunday, if you're doing some practicals, everything, nothing theoretical, everything will be practical here. But the initial just 1 to 3 sessions or 4 sessions, just a briefing about how this going to, but later everything will be practical, right? Up to the end of this course. Yes. And this is one of the uh, booming technology in the market, right? We say like we can go as data engineers, we say like big data engineers. Like even in that today, if we see that check in the Google, right? PySpark has got very great boom. Hadoop and PySpark means even they ask combination with Hadoop and PySpark, or even PySpark also they'll be asking. You can manage, right? But Python, even you need to have knowledge on Python. So yes.
Yeah, one question. I can see like the class is only Monday 6 o'clock only. So regularly 6 o'clock only, like it will change it to 8 o'clock sometime.
Which one? Which
Python class.
so okay. Python 6 a.m. class 6 a.m. batch is running, right?
That's correct. So it will go for only 6 a.m. only, or like some batches will start at 8 a.m. also.
No, 6 a.m. only. It goes at 6 a.m. only. There's a
So
batch
every
at
day,
yes.
every day 6 a.m. has to.
Yeah, 6
Okay.
o'clock. 6 o'clock only. Yes.
So too early. That's why.
No. There's no 8 a.m. batch at all.
It will not start January also. 8 a.m. batch.
You want 8 a.m. you're talking?
8 a.m. or 9 a.m. Yeah.
8 a.m. A morning 8 a.m.
Yes, correct.
It will start
Yes.
in January. You'll have a batch.
January mid. Okay.
It will be started. Yes.
Your class only, correct, right?
Yes. So
Okay. Python will cover both advanced or
core and
core.
advanced, everything will be covered.
But but data engineers we need advanced also, or only thing is core is enough.
See here, if you have got a get command on this, right, you need to have this Python core is mostly used, and also some parts of advanced used, right? Like modules,
Okay.
using of modules and object-oriented concepts.
Okay. So better have knowledge. That's what it is.
Yes. You need to have command because total coding implementation going in Python, right? You need to have the knowledge about all this.
Okay.
So those who wants to go for Python, right? 6 a.m. batch as of now, 6 a.m. evening 8 p.m. 6 a.m. batch and 8 p.m. batches are available as of now. Morning 6 a.m., evening 8 p.m. After some days, right? 8 a.m. may start in the morning. Yes. Any other queries, right? You can attend the session tomorrow also. Everyone, you can attend the session tomorrow using the same link to see more on this, right? Tomorrow I'll just go with the
One more
story.
thing, Linux, like when you cover, I mean,
What,
along
what?
with Linux commands only. Linux you mentioned here, correct?
Yes, yes. Linux commands I'll be taking separately, right? Before I go with the practicals.
That's 1 week, 1 week we'll take it, one
So
day.
all the commands I'll be discussing, right? What all the used. So here I was saying about this HDFS, right? To understand
Okay.
this distributed file system, HDFS also their commands are there.
Okay.
HDFS commands to understand this HDFS commands, Linux commands you need to understand first. So before I go with the practicals of this HDFS, right? I'll be briefing about all this Linux commands. I'll keep some separate time. Okay, I'll just discuss before I go with that Linux commands. So if you have got knowledge or if it doesn't have knowledge, you can attend that session, right? Basic Linux commands, right? All required for understanding this HDFS. Fine. So before that, I'll be briefing you about the software, the environment, other things, right? So yes. Okay, WhatsApp group will be created, right? Yes. Yeah. Once it is created, everyone will be added. Once everyone got enrolled, will be added. So from tomorrow, we'll be starting with this course, right? Any other queries, right? Yes.
No, actually, how much RAM size is required? Mine is 12 GB RAM.
So 8 GB and above is good, right? But if you have got lesser also, it works. But the speed will be less. Whenever you type any command, right? It takes, if you have got above 8, like 12 or 16, right? Immediately you get the response. But if you have got less RAM capacity, it waits for some 5 seconds, 10 seconds and gives the result.
Okay.
So
Okay.
if you have got good RAM, you will get the immediate RAM speed. And then that too in Spark, right? Which uses in-memory computation. Whenever you type, if you have got low RAM below 8, 8 is good, but above 8, if it is 12 or 16, it's fine.
Okay. Okay.
Okay, fine. So I'll stop for now. We'll continue tomorrow, same time at 2:30 with the same link, right? Fine. Thank you for your time. Thank you all.